Okay. Let me just tell y'all something real quick. I put my makeup on today to Zoom with my geometry kids. 6 of them showed up. But that was cool. It was fun to see their faces, so maybe we should do it sometime. I'm straight up pissed right now because no one at my house will go get me hot Southern made donuts. Just being real. Freaking jerks. Alright, anyways, I am going to teach you about radical exponents. And then this will be due on Monday morning. And then it's quiz time. Okay, so then you're going to have a quiz over everything that we've learned. Again, it's open notes and whatnot. So make sure you're asking questions and getting everything done for that. And if somebody could bring some hot donuts to my house right now, which is impossible because you won't see this until tomorrow, that would make me happy. Anyways, here we go. All right. So we are dealing with rational exponents. Okay. What we are going to do, you guys, is sorry, there's like all kinds of crap all over this. My child got this, but I'm not printing another one. So if you have a base raised to 1 over the n power, the n is going to represent the index of your radical. So it says the nth root of a. So if you get this, a, 1 over n, what you really have is a radical with an index that's n. So whatever the bottom is going to be your index. A is your number, and then whatever's on top is your exponent. So in this case, it would just be 1. So really, we would just write that n roots of a. Okay? Then for this one, it says a m over n. It says the nth root of a raised to the m power. So exactly what I just showed you. The n is the index. A is going to be to the m power. So whatever power that is. Okay, so let's look at some examples. So if we look at number 1, we have x to the 1/4 power, which means the index is 4. X is to the first power, or just x. This is all in parentheses, which means the whole thing is being raised to this exponent. If 2 is the index, you guys, you don't need to write that. Remember, it's an understood 2 if there's nothing there. 15n, the whole thing is to the first power. So I don't need to write that again because it's to the first power. Okay, over here, your index is going to be 3, 24 to the first power. Second row. Okay, 7 is my base, 3 is my index, and it is raised to the second power. So I'm going to go ahead and simplify that. That would be 3 square roots of 49. Now, if you can, you're going to continue to simplify. This one is not going to be able to, so I'm done with this one. This is the square root. The index is 2, k to the 7th power. There's no way for me to simplify that one. This one, if you look at this, your numerator is greater than your denominator, okay? I didn't do that for this last one. Reverse, go back. Okay, I did this wrong. Go back to number 5. All right, if the numerator is greater than the denominator, what you need to do is you need to separate it with whoever is divisible. So what I mean is that 6 divides evenly by 2. So I've got 6 divided by 2 times whatever is left over, 1 over 2. Okay, so what that is going to do is this is going to simplify and no longer give you a fraction. 6 divided by 2 is 3, k to the 3rd, which is just normal. There's not going to be a radical there. It would be like 3 over 1. There's no such thing as 1 root, so that's just going to simplify. Then this is what's going to be left in the house. So that is going to be the square root, so the index is 2, k to the 1st. I'm sorry, y'all. We could have simplified this one using our rules. 6 of those would have been perfect, and they would have come on the outside 3 groups and then 1 left over. So I apologize. But like if you look at number 6, that one, that 5 is greater than the 4. So I'm going to split it and say 4/4. That's a whole. That's going to be just 3 to the first or just 3. Then what's left over would be 1 to the 4th power. Okay, so that is going to be the 4 as the index, 3 to the 1st power. And that is your final answer. Okay. Okay, all right, so then we have this next one. The whole thing, AB, is in parentheses, so all of that is to the 3/4 power. 3 is not greater than 4, so I can't do what I've been doing on the other ones. So I'm just going to put the index as 4, AB, and I'm going to leave it in parentheses, guys, because I'm going to have the whole thing to the 3rd power. So then you could even go a step further and say the 4th root of A to the 3rd, B to the 3rd, because that 3 belongs to both of those. Okay, on the next one, again, 2/3 is not a whole, so there's no reason to break it up like I did on 5 and 6. So I'm just going to have an index of 3, negative 6x to the 2nd power. Okay, I'm going to take that a step further. Negative 6 to the 2nd power is going to be positive 36, and then x to the 2nd power. So now I have to think about that 36. Is there a perfect cube within 36? My perfect cubes are 1, 8, and then it jumps all the way to 64, right? No, 27 and then 64. So none of those are going to be divisible, or 36 is not divisible by any of those. So it just stops right there. All right, this 7 is on the outside of the parentheses, so that 1/2 only is for the parentheses that's directly in front of it, which is 12W. So that 7 is just going to be out there away from it on its own. Then you have the square root of 12W to the 1st power. Since it's to the 1st power, I'm not putting the parentheses in the 1. I just leave it like that. Okay? All right. Now, the reverse of that is if it's written like this. This 16 is to the 1st power. So this would be 16 to the 1/3 because your index is 3. So that's 16 to the 1/3 power. This one, XY, is what's inside. It's 2 variables, so I'm putting that in parentheses. It is to the 1/2, because if there's no index there, it's 2. 8W in parentheses to the 1/4 power. This is 11 to the 2/3. There's no reason for me to put that one in parentheses because 11 is just a one term, a monomial. So I didn't worry about that one. For this one, it would be k to the 5/4. Now, k to the 5/4 is one that has a greater number than 4, but we're not breaking this down. We're leaving it just like this, so that's what we would do. For this one, the entire thing is inside the radical, so I'm putting it in parentheses, and then that is going to be to the 7/2. Okay, for this one, I've got negative 2a in parentheses to the 5/4. This one, 10 to the 5th power, a to the 3rd power, b, and I'm raising that to the 1/2. Okay, over here, I've got 9, x to the 7th, y to the 4th in parentheses, and I'm raising that to the 1/3. Okay. Okay, that's the first page. Moving on. Now, we are going to be simplifying expressions with radical exponents. So we have to remember the rules for our exponents. I know I sang this to you. I'm going to do it again. When you multiply like bases, add exponents. When you multiply like bases, add exponents. When you multiply like bases, when you multiply like bases, when you multiply like bases, add exponents. If you put that on TikTok and make me famous, I want my cut. You hear me? Okay, moving on. Sure. I'm being silly tonight. Okay, so I'm going to get serious and finish this. I realize, like, none of you watch this, so I'm just being silly. So, when you multiply like bases, you add the exponents. So, since these are like bases, I'm going to add my exponents together. When you add fractions, you just add the numerators. So, that's going to be 5/3. Now, again, you're looking at a numerator that's greater than the denominator. So I'm going to take out a whole 3/3, and that's going to leave me with 2/3. Okay, so 3/3 is 1, so that's perfect. It's not going to be in the radical. This is going to be in the radical like so. And that is your answer. Okay? When you multiply like bases, you add exponents. Now, I cannot add those two things together in their current state. I need them to have common denominators. So I need to multiply by 2 on both the numerator and the denominator, and then I can add those together. That's going to give me P 7/4. Okay, and then I'm going to separate that into 4/4, which is a whole, and the remainder, which would be 3/4. 4/4 is just a whole, so that's just P, and then we would have an index of 4 and P to the 3rd. That would be your answer. For the next one, when you are dividing like bases, you subtract. Again, in order to subtract, I need them to have the same denominator, so I need to do 10/4, and then I subtract. 10 minus 7 is 3, so that's going to be 3/4. That is not greater than, the numerator is not greater than the denominator, so that's just going to be the 4th root of m to the 3rd. When you raise a power to a power, you multiply exponents. And when you multiply fractions, you just multiply top, top, bottom, bottom. So this is going to be a 5/6. Okay, 5 is less than 6, so this is just an index of 6, a to the 5th power. Okay? Over here, when you raise a power to a power, you multiply. So that's going to be 32 to the 1/4, the 4th root of 32. And then we need to simplify that. There is a perfect 4th root within 32, that's 16. 16 is a perfect 4th root. 16 times 2. The 4th root of 16 is 2. 2 to the 4th power gives you 16, so that would just be 2. And then this 4th root of 2 stays in the radical, like so. So that is your answer. Okay? Okay, for 24, you have to raise a power to a power, but you have to apply that to the 8 and the x to the 2nd. So we're going to have 8. It's currently just to the 1st power, so it's going to be to the 2/3 power times, when you raise a power to a power, you multiply. So that's going to be 4/3. Okay? So 8 to the 2/3. That is saying,
oh, it's not
the 3rd power,
let me upgrade this
8 to the 2nd. Okay, and then you've got 8 to the 2nd power. I'm just going to extend this line because, you guys, this index is also 3, so it can be underneath that same radical. It's just going to be x to the 4th power. Okay, now 8 to the 2nd power is 64. X to the 4th, this is all underneath the cubed root. So again, we're looking at our cube root 64, and we're trying to think about how we could simplify that. Well, 64 is a perfect cube. Okay, if you're not sure of that, you could use a calculator. if you had this one, you would go to Math. There's your cube root number 4, and you type in 64, and that's just 4. So it is a perfect cube root. Now, x to the 4th. There are 3 x's. That is one perfect group. So I'm going to take those perfect group. So there's 4 x's. This perfect group gets to come out. And so the only thing that's going to be left underneath the radical is the single x, because everyone else is perfect. Okay? Now, number 25. Because number 25 is negative, that is to the negative 1/2 power, I'm going to address that and put the whole thing under 1 and make it positive, because anytime you have a negative exponent, that shoots it down to the denominator, and then we just need to address the denominator. So we've got 1 over the square root of 100. I didn't put an index there because it's a perfect square. 100 is a perfect square, so just 1/10 is the answer to that one. On number 26 right here, we have like bases, so again, we are multiplying those. Y'all, I'm going to switch over to the key and just talk you through those, because these are just more practice problems, and I think I could probably do it quicker just showing you guys the key. Okay, what number were we on? All right, so here we are, 16. This is negative. These are like bases. When you multiply like bases, you add exponents. So 2/3 plus negative 1/3 gives us 1/3. 3 is your index, 16 is there. You have to break it down using the perfect cube, which is 8. The cubed root of 8 is 2 on the outside, and then that has to stay on the inside. Number 27. This is negative. That's fine because your index is 3. Now, it's also negative. It's hard to see on my screen. Let me see. How do I zoom this baby in?
I'm trying to take out our debit account.
There we are. So it's negative. So that, again, 1 over that. They went ahead and put it in the radical to the first power, so that's fine. This is a perfect cube, so it's going to have -6 on the bottom. Number 28. If you look at number 28 right here, they have, again, a negative. So instead of it going under 1, the numerator and the denominator swap. You see that? They swap, and then it's to the positive 1/4. Now, this is able to simplify. So if you can simplify, do that first. So they simplify that to 1 over 16. This is going to be the 4th root. Now, she took a shortcut and didn't actually show that, but the 4th root of 1 would just be 1. The 4th root of 16 is 2, so that gives you 1/2. 29. You are multiplying like bases right here, but they're in different radicals. This is the 3rd root and this is the 2nd root, so we can't combine them at this point, so we rewrite those as their exponential value. Now that they're written like this, then we can multiply. So when we multiply those together, I don't know how she got 5, 6. I think she made a mistake. This should be 1, 6 because you multiply top, top, bottom, bottom. So that should be 1 over 6. Now 6 is still your index, but 1 is going to be the exponent that goes with that. Over here, same thing. This is the 4th root, this is the 2nd root. So currently we cannot combine those. So we have 4 to the 3/4 and 4 to the 1/2. Then you multiply. When you're multiplying like bases, oh, y'all, when you multiply like bases, you add exponents. So back to this one, I'm incorrect. 29, I'm incorrect. When you multiply like bases, you add. These are not the same denominators. So let me switch back over since I messed this problem up. I want to work this one out. Okay, so when you multiply like bases, we have v to the 1/3 times v to the 1/2. When you multiply those like bases, you are going to add the exponents. 1/3 plus 1/2. Now, we cannot add those because they don't have the same denominator. So we give them the denominator of 6. So we have to multiply by 2. So this is 2/6. Multiply by 3. So this is 3/6. So that is how she got 5/6. So she is correct. I am incorrect. I apologize. So then from there, your index is 6 and it's v to the 5th power. My bad. Over here, same thing. This would be r to the 3/4 power, and then this is r to the 1/2 power. When you multiply like bases, you add the exponent. So I'm adding those together. I need to change that to 4, so that would be 2/4. 3 plus 2 is 5/4. So this is r to the 5/4. Okay, so if I'm taking that to the next thing, am I doing this right? Yeah. Okay, if I'm taking this to the next thing, I'm going to know that that numerator is greater than the denominator, so I'm splitting that into 4/4, which is a whole, times 1/4. 4/4 is just going to give me r to the 1st on the outside of the radical. This is the 4th root of r to the 1st power, which is just r. Just like that. Okay. All right, so 31. Here we are looking at this. This is in a radical, this is not. So I'm going to rewrite my denominator as 4 to the 1/3 power, and this would just be 4 to the 1st. Not a fraction, just the 1st. Well, the rule is when you are dividing like bases, you subtract. 1 minus 1/3 is 2/3. Okay, so that's 4 to the 2/3. Then you could take that and simplify it. The 3 is your index, 4 to the 2nd power. 4 to the 2nd power is 16. Okay, so cube root of 16 is not perfect, but 8 is, and 8 is a factor of 16. I'm going to come over here and give myself some space. So I've got the cube root of 8 times the cube root of 2. 8 is a perfect cube, so 2 cube roots of 2. Over here for 32, I am going to rewrite, well really this one I don't really think that you have to, because this is a this is a square root and this is a square root, so really you could just do 3 minus 1, which is going to give you 7 to the 2nd power underneath the radical. Well, the radical and the square are going to cancel each other out, just leaving you with 7. Now let me show you what she did, because she didn't do it that way. She, you can see, rewrote this as 3/2, and this is 1/2. Then she subtracted 3 minus 1, that gave her 2/2, which is just to the 1st power, so she got 7. So she gets the same thing I get, she just did it differently. On this one, we take that 10 and we put it over 4. Then you can simplify that to 5/2. 5 is greater than 2, so you split that up. 4 over 2 is perfect, which is just 2 on the outside, x to the 2nd power. 1 over 2 would be an index of 2, x to the 1st power. Over here, we are going to take each one of these and do them individually instead of doing them together. So you take this 25, that's to the 1st power, so that would be 1/4. M is to the 2nd power, so that's 2/4. Okay, so right here you can see that she took this 25 and she wrote it as 5 to the 2nd power. Okay, those are the same thing. They are equivalent. Then you can raise a power to a power. That's going to be 2/4, which simplifies to 1/2. Over here you have M. You simplify that to 1/2. That gives you M to the 1/2 power. So then those are going to have the exact same radical. you would put them underneath the index of 2, both to the first power. So that's how that one would be simplified. I probably wouldn't have done it that way, so let me show you guys how I would have done that one. 34. And that's the thing, you guys, is that there's no right, specific way you have to do these. You can kind of just do it whatever is best for you. I probably would have taken this and put this in parentheses and put the 4 on the outside. Or not the 4, I'm sorry, the 1/4. Okay, so that would be 1/4 like that. Then I would have raised the power to the power. So I would have taken this and I would have raised that to 25, which 25 is to the first power. So that would be 25 to the 1/4 power. And then I would have done 1/4 times 2, which that is what gives you 2/4. So that's probably how I would have done it and thought about it that way. And then I have the 4th root of 25 to the first. Now, 25 and 4th, you have to think about your force. The perfect force that we have are 1 to the 4th power, which is 1, 2 to the 4th power, which is 16, 3 to the 4th power, which is what? Something big. 3 to the 4th. So 81. So that's why she did it that way, because I get stuck. There's nothing that I can do right here. I'm just stuck at this point. So she continues to simplify by taking that 25 and changing it to 5 to the 2nd power. So that's a pretty advanced problem. But now that we've seen her do it, like, we can do that too. You just have to take this 25, write it as 5 to the 2nd, which is equivalent, and you raise that to the 1/4 power. Okay? So then when you raise a power to a power, that's how she gets the 2/4. That simplifies down to 1/2. Okay? This m over here to 2/4 also simplifies to 1/2. So that would be like the square root of 5 to the first and the square root of m to the first. And since both of those are in the same index of 2, which we just don't write, then you would just multiply those together, which would give you 5m. Okay? So that's a kind of a hard problem, but you can do it. You guys are awesome. All right, so you do have homework. That is going to be due on Monday morning. So you have today, all of today to do it, and then also this weekend if you need extra time to do that. And then the next thing on the agenda is a quiz. This is a 28-minute video, so if you are still watching this video, I love you. You're amazing. Have a great weekend. I hope that today is awesome.